both methods kind of at once. You want to pick a method and totally just go with that method. So I'm gonna kind of do this on two separate sheets. I'm going to do one way, and then on the other sheet I'm going to do it the other way. I think it's going to work the best. So like the square root of 50, we already sort of did. Well, we already did it. Yeah. So one way to do it. The way that I'd like is this, because it's very in your face about what's happening. So a lot of you guys had trouble because you're not sure why things are happening. This is very in your face. That is totally true, right? Wherever I see 50 in the universe, I can replace it with 25 times 2. Because it's still frickin' 50, right? So what good does that do me? Well, now I can break this up. It's the square root of 25 times the square root of 2. This is why I like this method, because there's no ambiguity about why things are where they are. What is the square root of 25? 5. What is the square root of 2? I don't frickin' know. Right? It's exactly like here. What's 17 divided by 17? 1. What's 7 divided by 17? I don't frickin' know. So I write it. There it is. I don't know. There it is. Do you guys see that? It's exactly the same idea. All right. So the other way to do this is to take this and break it all the way down. Any 2 you see. This is why I don't really like this method. But if this method makes sense, totally do it. But it leaves it very open for students to put things in the wrong places. Any 2, since it's a square root, what's it looking for? Square root's always looking for groups of 2 things. So the square root of 5 times 5 is 5. And what's still on the inside?
2.
This extra 2. But see, this method requires you to realize what the hell you're doing. What's coming out and why, what's left. So I always tell students, if you want to do it this way, cross through what you used so you know exactly what's left. Okay. So if you like this method, do it, but just understand that it's some organization. This, there's nothing to have to organize. You just do it, bam, bam, bam. Everything's right where it's supposed to be. You see how I'm trying to push you a certain way? But if you like this method, do it. All right, so what about this guy? Well, again, I'm going to do this purposefully, not quite fully, just so you can see you can do this several times. You can do 9 times 8. Why is that a good thing to do? Because square root of 9 I can do. So I can rewrite square root of 72 as square root of 9 times square root of 8. That's the same thing, right? Because 9 times 8 is 72. What is the square root of 9? 3. But what can I do with square root of 8? 8 is 4 times 2, right? So I'm just rewriting. I just rewrote what square root of 72 was. Bam. And then I can simplify a part of it. I'm rewriting what square root of 8 is. Bam. I can simplify this. What's square root of 4? 2. So I get 3 times 2 times square root of 2, which is 6 square root of 2. Now, the more direct way to get there with that method would have been to say square root of 72 is square root of 36 times 2. Square root of 36 is 6. Square root of 2, I don't know. Bam! But if you don't happen to see that bigger number, who gives a shit? You just do it several steps. Sort of like if you don't happen to reduce a fraction all the way the first time, who cares? You just keep reducing. How are we doing so far? So what's that look the other way? This method, if I do it this method, I break 9 times 8, 3 times 3 times 2 times 2 times 2. So I got 2 3s, a 3. I got 2 2s, a 2. And what's left inside? The extra 2. That's the correct way to do that method. That's the correct way to do it. It's a square root, so I'm looking for pairs of numbers. I know. Holy crap. I think a club opened up next door. What happened? Gross money. We have to make money somehow, so we're running the rooms out. So this becomes 6. Everything is multiplication, right? I'm breaking up into factors, so I multiply by extra stuff that keeps coming out. How are we doing so far? Is this making a little more sense, or... All right, maybe a little bit. Some of you guys are averting thine eyes from mine. Okay, I understand. Like, don't look at me. All right, this one. What squared number definitely goes into that?
6 divided 2. No.
Well, 5 is not a square number. I mean, like 4, 9, 16. 10 is not a square number. 5 is not a square number. 4, 9, 16. Those are square numbers, right? 4 times 30. Square root of 4 is 2. Square root of 30 is square root of 30. 30 is 6 times 5. Is there any squares inside of 30? Do you guys understand? So why was I able to do the first step? Because is there a square inside of 120? Yes, there's a 4. So that means I can do something. I can simplify. I can break it up. Is there a square inside of 30? No. It's 5 times 6. There's no square inside of 30, so I'm done with it. That's where I stop. I can't break that up any better. So what's it look like the other way? Well, this way it gets a little bit messy, but oh well. So this would be like 12 times 10, which is 2 times 2 times 3 times 2 times 5. How's that? 10 is 2 times 5, 12 is 2 times 2 times 3. Is that cool? What am I looking for? Groups of? Why? It's the square root. So I see a group of 2 2s, so a 2 comes out. Do I see any more groups of 2? No. So then I'm done. Square root of 6 times 5 is 30. Either way you do it, you get 2 radical 30. But pick a method. Pick a method you like better. And you're like, I don't like either way. Oh, well, shit. Close your eyes. Flip a coin. All right, so now think about this. So 80. If I want to attack it the way